All right, here's a quick little scribble cast that deals with graphing things. You've probably seen lots of different graphs for different relationships. This looks like a population of a world going up. That's an exponential graph. This almost looks like a backwards or an upside down parabola. That one sort of looks like a square root function combined with some other kind of function. But you see some patterns in there. In order to deal with graphs or look at relationships between things, we need to be comfortable with plotting points and looking for those the patterns. For example, in this one, we're looking at some corporate bonds. It almost looks like there's a downward trend. Yeah, there's a few bumps and mountains and valleys, but typically we're looking at a downward trend. So, the purpose of this chapter is actually to look and be good at graphing things. And we're specifically going to look at straight lines. Before we get into straight lines, though, we need to be able to plot some points. So here's just a couple of definitions. When you're looking at a graph, and this thing here is called the quadrant. Some people call it the Cartesian plane or something like that, but we'll call it the quadrant. When you're looking at how it's split up, first off, we have what we know is called an x-axis, and that's this, whoops, come on, that's this horizontal line. Won't get off, stop, there. So that's this horizontal line. The y-axis is this one, a vertical line. Sometimes they call the x-axis the first axis, or the independent, or the abscissa, and the y-axis sometimes is known as these names, but typically we're going to call it the axes. Also, you notice that these two axes split the quadrants into four. I guess that's why it's called quadrants. The first quadrant is up in the top right corner, second quadrant is here, third quadrant's right there, and fourth is right over there. So they sort of go in a counterclockwise way. This one would be quadrant 1 though, then. So if I want to identify a spot in the quadrant, it's like the old battleship game where you go A4 or something like that, but you have an ordered pair that indicates where you need to be. Same thing in a quadrant. And what we do is we write the ordered pair within brackets and a comma in the middle. The first one refers to how far left or right you go, and the second one refers to how far up or down you go. A lot of people get those confused, so be careful with that. First left, right, second one up, down. Okay, so let's take a look at a couple points and maybe plot them. So this 4 tells me to move right 4, and where I'm moving from is from right in the middle. So this point here, right there, where the dot is known as the origin. So from the origin, I'm going to move 4 over to the right. There's 4. And I'm going to move 5 up. 1, 2, 3, 4. Is that 5? No, right up there. So that point right there is the point 4 over and 5 up. Here's another one. Negative 4, 0. So I'll start here and I'll go over 4. 1, 2, 3, 4. But then I don't go up any. So that's where I'm going to stay, is right there. Now over and down a little bit. Okay, negative 3. Why don't you try the rest of them? I'll plot them. Hit pause and draw yourself a little quadrant and see if you can get them where they should be. Okay, so negative 3, 4. So negative 3 and down 4. Down 4, right about there. Over and up a little bit. Okay, 5 and 4. I'm just going to draw a dot. 1, 2, 3, 4, 5, and up 4. That would be that point right there. 0 minus 2. 0 means I don't go left or right anywhere, but I go down 2. So that point right there would be that one. And the last was minus 2, 5 would be minus 2 over left 2 and up 5 right there. So that would be that point. You might want to practice those if you haven't done them before. So just as a quick review, which is quadrant 1? Hopefully you picked that one. Quadrant 2 here, 3 and 4. And hopefully you can label those points too. Minus 6 and minus 4 would be down here somewhere. 0 minus 3 would be right about there. You want to get so that you are really quite good at knowing exactly where those points are, because we do lots of that. Okay, now that's plotting a point, but now we also need to identify some points. So if I wanted to identify A, I first from here have to tell it how far left or right I go. So I go right 1, and then I go up 1. So that would be a positive 1. Let's try C. I'd go left 1, so C is left 1, that's negative 1, and up 1, 2, 3, 4. Up 4. You getting the idea? Maybe try the rest of them and then check back to see if you're right or not. B would be negative 6, negative 5. I'm betting D, 5, and 0. Careful, a lot of people want to put 0, 5 there, but I always think left, right first, up, down second. E would be 0, left or right, and then down 4. And lastly, F would be over 5, right, so right 5, and then down 3. Okay, hopefully you're getting those, being able to label those points like that. Now once we have an ordered pair, we can start looking at a relationship between values for x and y. In this case, they did a and b. Typically, we always put an x and a y there, but if they give you different letters, just make sure the order would be in alphabetical order. So they're saying I have a relationship here, which is a line. I don't know what the line looked like. Probably something like, I don't know, something like that. And they want to know if this point is on the line. Well, you could draw the line, I guess, as long as you're accurate, and then just see if that point 1 minus 3 is on the line. The other thing you can do is plug in those points. Again, they're ordered, so this one's got to be A and B. So I could take the equation, and I could plug in a value for A, this is 1, minus 5 times B is a negative 3, is equal to 17. Now, if it's equal to, then that means that point is on the line, and that I've drawn my line incorrectly. Okay, let's see. 2 times 1 is 2. Minus 5 times minus 3 is a positive 15. Sure enough, 2 plus 15 is 17. Therefore, yes, it is. That point would be on the line. So where I drew my line here would be incorrect. My line would have to be something like this. That it would go through that point 1 and minus 3. Okay. So when we're looking to graph a whole relationship, here we were just checking to see if that point was on the line. But if I wanted to graph a whole thing, what I could do, one of the ways I could do it, is to get a bunch of ordered pairs and just plot the points. So these instructions sort of tell you what to do there. So pick a number for one of the variables and solve for the other one. And that'll give you an ordered pair. And then you want to get about 3 of those. I like to get 3 or more. And then once you have them, plot them on a graph and join them. So let's try it a couple times. So here's an equation, and they want us to graph that. So it's showing a relationship between x and y. It says that to get any y value, take the x value and times it by negative 2. So let's try that for a couple points. I use these ones, but you can try any numbers you want. So if I say for x is equal to 0, I'll go y is equal to negative 2 times 0, which is equal to 0 times anything is 0. So the point 0, 0, that's an ordered pair. I guess I could write that right here. That's an ordered pair that must be on this line. I'll plot that right there. Now I can't draw a line yet from that because I don't have another point. So I need to do another one. Let's do for x equals 1. So for x is equal to 1, then y is equal to negative 2 times 1, or negative 2. So my point would be 1 and negative 2. Let's plot that 1, negative 2 right there. So there's another point. I'm tempted just to draw my line because I know it's going to be something like that. Never a bad idea to check though with a third point. If the third point is in direct line with those ones, I know I'm good. Plug in a 2. Okay, so for x is equal to 2, y is equal to -2 times 2 or -4. So my point is 2 for x and a -4 for y. So 2 and -4 right there. And now when I take a look at them, sure enough, I'm going to have a line that goes between those guys that looks something like that. I probably should continue the line up higher too. Let me just do that. So that's what my line would look like. Okay, so I've got my 3 points. I guess I should have put them in there. When x was 1, y was -2. When x was 2, y was a -4. Okay, and I could keep going the other way. Maybe try this one. Plug in some numbers. I gave 0, 1, 2, 3, but plug them in and see what you come up with. And then press play again and see if you're right. So for x equals 0, I'm just going to try and do it in my head. 0 times 2 is 0, plus 3 is 3. So my point would be 0, 3. 1. So if I put a 1 in there, 2 times 1 is 2, 2 plus 3 is 5. There, I've got 2 points. Let's do the third one. For x is 2. 2 times 2 is 4. 4 plus 3 is 7. Okay, so let's plot those points. So 0, 3. So 0, 1, 2, 3. Right there. 0, left, right, nothing, up 3. 1 and 5. 1, 1, 2, 3, 4, 5. Right there. And 2 and 7. 2 and 4, 5. Uh-oh, 6, 7. Somewhere up there. I don't know if that's perfect or not. Maybe I should have done one on this side. Let's plug in a -1. So y equals, I can't do this one in my head, 2 times -1 plus 3. This is for x equals -1. 2 times -1 is -2, plus 3 is equal to -1. Oh no, positive 1. Positive 1. So that's another point. So -1 and positive 1. Now when I take a look at them and I go to draw my line, that's going through all those points. That line's looking pretty good. So that would be the graph of this line. We can try another one. You can try this one if you want. This one has a fraction, but you do the same kind of thing. Plug a 0 in. 0 times anything is 0. Plus 2 will be a 2. So that's a 2. If I plug a 1 in, 3/5 times 1 is 3/5. 3/5 plus 2 would be 2 and 3/5, or 2.6 about on the graph. So 1, I've got 1 here. No, I don't have 1 there. 0 and 2, 0 and 2 right there. And 1 and 2.6, 1 and 2.6, not about there maybe. And I could keep going. Maybe let's do 5. 5 might be a good one because the 5s will cancel out. If I put a 5 there, 5s cancel. 3 plus 2 is 5. So the point 5, 1, 2, 3, 4, 5, and up 5, 1, 2, 3, 4, 5. There's another point. And if you take a look, sure enough, I'll bet that line's going to go smack dab through all those points. Just one thing about this line, the line would have an infinite number of solutions. Like I can keep plugging numbers in. I could plug in 1 billion. I could plug in 0.2, whatever number I want. But all of the points that I get from there would fall along that line somewhere. Okay. I didn't draw an equation for that one. Let's try another one. Oh, this is a different one. It's written in a different form. That's okay. Let's try it. So x is 0. So for x is equal to 0, I'll go 3 times 0 plus 2x equals 0. 3 times 0 is 0, so really have 2x is equal to 0. Divide both sides by 2, and I get x is equal to 0. So I have a point right there. Okay, plug in a 1. So for, you know what? This was backwards. Ooh. I actually, for this one, did a y equals 0, didn't I? Because I put a 0 in there. Didn't notice that. But if I put a 0 in for y, in this case I would get x is 0, so this point is still valid. Sorry about that. Let's try another one. Let's say for x is equal to 1. So 3y plus 2 times 1 equals 0. Or 3y is equal to 2 times 1 is 2. If I move it to the other side, it'd be negative 2. Divide both sides by 3, so you get negative 2/3. So for x is 1, y is 2/3. So x is 1, y is negative 2/3. So that'd be a point right about there. And again, you can keep going. So it's the same game with any of these. You plug in a number and then solve for the other letter. Make sure you put that in here for your ordered pair, and then go from there. Let's just do one last one. For x equals 3. For x is equal to 3, so it'd be 3y plus 2 times 3 is equal to 0. And that would be 3y plus 6 equals 0. To solve, it would be 3y equals negative 6. Divide both sides by 3, I get y equals negative 2. So at x, a positive 3, y is a negative 2, right down there. And if you take a look, those points seem to be following pretty good in line. Okay, so that gives you a little bit of start on knowing what a quadrant is, quadrant 1, 2, 3, 4, and how you can graph any ordered pair. Something like that would be 2, negative 3 down there, and also how you can take and graph any linear equation.